Okay, so here's a section where they describe the, to the extent possible, that was done in the paper, the cohort criteria. And we'll just go through Atlas together. So this screen is the cohort definition page of the Atlas tool. And where we were speaking earlier about defining a cohort as first an initial event, and then once you have that initial event, you can further specify it with a variety of inclusion criteria. So in this top screen, you would see cohort entry events, and you would add one over here. This is if we were to add another. You say drug era. You say a drug era of dabigatran. Dabigatran has been previously defined elsewhere in Atlas as a concept set. And you would say import, and you search for your concept set, and you would enter it here. These are new user cohorts, so we say this is the first time in a person's history that they've been exposed to this drug. The era start has to be on or after this date, which was the date used in the study, October 19th, 2010. And then these people need to be greater than or equal to 65 on the date that they were first exposed to dabigatran. And then lastly, they need to have 6 months of continuous observation before this event, so that when we go to look at this person's medical record in order to balance them with the other cohorts, we know there's at least 6 months of data with which we can do this. Yeah? Oh, this has already been defined in Atlas. Yes, you can click through your own Atlas if you want to just sort of to navigate it a little bit. But this has already been defined, and I'm just going to walk through what it looks like. Yes.
You're using a J&J instance.
Yes.
So that we could replicate you don't want to try using AWS?
It would definitely take more than an hour to go and create all of the concept sets and cohorts to do this. But this is what you will do later this afternoon. We're going to all go through and do it together. This is just a walkthrough of the study that we're trying to replicate.
Okay. So it's the see one, do one, teach one. This is like the third time I've done this. So.
See one, do one, teach one.
Yeah,
Yes.
I'm in the teach now.
Yes.
And then I'm done, right?
They say, Reddit, I haven't even taught it.
So remember, after we do the initial event, there are subsequent inclusion criteria that are required to further restrict your cohort. And if we were to just scroll down a little bit, we see in this inclusion criteria window that we have 8 of them specified. So what you would do is you would click this button to create a new inclusion criteria, which gives you the options to then add various criteria. And in this first inclusion criteria is that the patient had prior atrial fibrillation or atrial flutter. So you can see that this having any, this is definitely different than having all or having at least. This is having any, so this creates an or situation between these two condition occurrences. Have at least one occurrence of atrial fibrillation in the all days before and 0 days after the index start date. So the index start date is the first time in the person's history that they have a recorded drug era start of dabigatran. And then, or at least one occurrence using all occurrences of atrial flutter, and this event needs to have started any time before and 0 days after the index start date. And like, if you find this language kind of odd, like why would no one speaks like that? That's true, but if you need to start pegging your inclusion criteria off different parts of the initial event, it makes a lot more sense. Sometimes you want to peg it at the end of your initial event, the end date of your initial event, or sometimes you want to make sure that the event, your inclusion criteria happens sometime in a window surrounding the index date. There's a lot of flexibility to this funny language. And then, in order to make sure we don't have patients that are in both cohorts, we've specified this specified the dabigatran cohort to make sure that this person that these people have no prior treatment with the comparator drug, with warfarin. And I'm not going to go through all of these, but you can look through and see that all of the inclusion criteria that was included in the paper is specified here. Yes?
So, everything you choose as a inclusion criteria, one of the things is all dependent on what database you're connecting to. Like you're gonna include the drugs not database.
Yes. So this is being built off of the vocabulary, like all of these concept sets. All these concept sets and conditions and events exist in a vocabulary, and you're creating this cohort definition independent of any database. The idea is if you then go and, this is an anticoagulant study, if you did this on tried to execute this on a CDM of a cancer registry, you might not see any patients, but like the definition of the cohort is independent of the database.
Yeah, so we don't have any time really to go into any of these code sets that Jamie is using, but can you maybe just show one as an example?
Sure.
Like the DABI one, maybe.
Oh, okay.
All right, or that one.
Yeah, so here's deep vein thrombosis. So this deep vein thrombosis concept set includes all of these, includes the concept for venous thrombosis, venous embolism, but does not include the subsequent 7 or 8 other non-related codes. And every entity that's referenced in a cohort definition, there it is. Every entity that's referenced in a cohort definition has its own concept set that you can see here. So this particular cohort has 9 concept sets in it. So your dabigatran new user cohort is defined by, includes in its definition these 9 concept sets: atrial fibrillation, atrial flutter, no rivaroxaban, etc.
I have a question on the venous thrombosis example you gave, right? So we use common data model. I remember when we did the other project, in the Grams paper, they use ICD-9 or ICD-10. So I thought they were not always one-to-one matching. So in our situation, when we try to, did we use all the code based on the ICD-9, ICD-10, or we actually eventually convert to our common data model because they are not one-to-one?
They're sometimes not one-to-one, and the vocabulary mapping piece, like there are common data models that map the structure from a source database to a common model, but they retain the content and they only make the structure common. But what's unique about the OHDSI or OMOC common data model is that there is a content transformation as well. And the reason for doing that is so that this can be a truly international collaborative, and databases from all parts of the world can move their the content of their database to a standard form as well. But it creates this issue that you're pointing out. Like, what about this one particular ICD-9 code that I'm really concerned about? But there's been a lot of work to see whether there is in fact any useful or relevant information loss in that mapping, and it's pretty minuscule. And I know that there are like studies, and if you're replicating a study, you absolutely need that one ICD-9 code, but a lot of the time you don't. It doesn't end up being a important part of your study. And there are ways, like if you actually really do need a particular like ICD-9 code that doesn't map to SNOMED, you can build this off of the source data. You can point it to, like, the CDM transfers and puts all of the source content into each of the tables as well. So you can look for an ICD-9 code if you must, but it's not really recommended, and it usually doesn't make a difference.
Yeah, I think it's, again, in the context, if we replicate the study, truly replicating the study, you will want everything totally safe, right? And we already have challenge in terms of we don't know how to do it.
Yeah.
So we are not going to exactly replicate the study because there are lots of unknowns.
Yeah. So if the qualitative result is similar, actually, the quantitatively they're different, then maybe you should other things you need to investigate. Okay. So they're not exactly.
So in general, when you're not trying to replicate an existing study bit by bit, the recommendation is you use the standard concepts, and like in the concept set that Jamie was showing, you include concepts typically and all of their descendants. That's typically the way how you find a specific concept of interest.
There is a deep, dark, black hole of vocabulary mapping that anyone is welcome to go to if they're really interested in it. And Christian and his colleagues won the award for it yesterday because it's hard and you never come out of it. So good for them. So yes, every entity in a cohort definition is references to a concept set. This is so we just looked at the dabigatran cohort, and here we are. This is the warfarin cohort, and the vast majority of the criteria in this cohort is identical to the dabigatran cohort, except the initial event drug concept has been changed. So now we're looking for warfarin rather than dabigatran. And if we look down here, we see that they have no prior treatment of the other drug, which in this case is dabigatran. Other than that, these are identical. And this is part of the way that a new user active comparator cohort design tries to approach this idea of exchangeability at that decision point. So these people, or at least we're trying to make sure that the people that get into these cohorts are the same in every respect except for whether they took warfarin or dabigatran. Of course, that's not the case. We see in propensity scores that they don't overlap, but this is the first approach. The active comparator approach tries to make them the same from the cohort definition, like from the get-go. You can, after you define your initial inclusion criteria, you can then see how many patients you lose from your initial event for every new rule that you put in. And we can see here that you lose, you say blah, 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 this is dabigatran, and then you say that they have prior atrial fibrillation, and some 50% of the patients disappear. And you can see how each subsequent inclusion rule can remove patients from your group. And you can see assess the impact of your inclusion rules by looking at these plots. So here's the outcome. We were talking earlier about like how did they define the outcome. We got some codes and a positive predictive value, but it's really it. Here's something that someone pointed out, that if you actually read the validation paper about ischemic stroke, it says very clearly to not use primary discharge only, but this Graham paper used primary position code only for stroke. So they referenced the paper but didn't quite do it as the paper recommended. But anyway, so the same way that we would define the T and the C, we would also define the outcome. So here we have the initial event is a condition occurrence of ischemic stroke, and unlike the T and the C's where we specify the earliest event per person, we've now left, it's still earliest event. We want incident stroke here. But we have a condition occurrence of stroke. The condition type is in inpatient primary, inpatient header primary condition, inpatient detail. These are all condition types that are associated with condition records to indicate whether they were in the primary position on the claim or on the claim. And like we said, this is probably, according to the validation paper that was referenced, this is probably not something we want to do. And the ischemic stroke has to have happened in the ER or inpatient setting. There are no additional inclusion criteria for this. But again, like usual, this relies on a concept set, and in this case it's ischemic stroke. And so this ischemic stroke concept set, like the cohort for ischemic stroke, the concept set is reusable as well. So whenever you want to, maybe you want a different definition for ischemic stroke for some reason or another, you could reuse this concept set definition in that approach. And then, because it's hard to read one of these, if you want to communicate the exact definition of your cohort, you can use this amazing part of Atlas where you go to export and you get an English language version of exactly what you've done. This language is not like what you've just read in the Graham paper, but this is, it's kind of tricky to read. It doesn't exactly flow beautifully, but it is an unambiguous description of what we just used the GUI to enter. So you can see, for example, the initial event is people having any of the following: drug era of dabigatran for the first time ever, 183 days of continuous observation, and then all of these inclusion rules, having at least one occurrence of conditioned occurrence, etc. And then if you don't like reading this kind of English, you can look at it in SQL in all of these different dialects. And one way to
I read that in JSON.
okay, or if you're Mark, you can read it in the JSON representation, which is all right here. And what you can do is you can copy this JSON right here and email it to your friend who has Atlas somewhere else, and they just punch it in and they have the same cohort definition. So these things are very modular and transferable.
Can you click on the graphical view?
Click on the what?
Graphical.
Oh, the graphical view, yes. So here. So here's the first drug era of dabigatran. It has to start after this date. And then here are some inclusion rules. Atrial fibrillation, there needs to be at least one occurrence in the 180 days before this dot, which is the index date, and goes down. This is, this is less digestible maybe than the JSON.
Slightly less.
Yes,
So JPT, yeah, could you go back to the print friendly?
yes.
So one thing that we've been doing is we've actually been copy pasting this human readable description into our protocols, even the ones that we sent to regulators for approval. And so we've gotten feedback saying, well, this is a bit weird language, and it reads as if it's a programming language, and no, it's not a programming language.
With
But-
derogatory connotations, it's like,
Yes.
did a programmer write this?
But we've actually been very stubborn and say, no, we're not going to change the wording that we use to the wording that's, for example, in the Graham paper, because even though this might feel a bit artificial, this is actually an unambiguous description of what we will do. And what Graham did is maybe nice prose, but it's not unambiguous. So we've been trying to push back a little bit, saying, well, you really want this, even though it reads a little bit hard. It might be a little bit like legal language, and that it's hard to read, but it's unambiguous.
Yeah, legalese. Now there's
Yeah.
epidemiese or something.
There's oddities.
Yes,
Oddities.
oddities. But anyway, and then you can do this with any of your cohorts, and you can look at the, here's the print friendly of the outcome cohort. And of course, if you scroll down, we didn't see this in the other ones because I didn't go down far enough, but if you then, in the print friendly, you scroll down a little bit, then you also see the concept set that was used to populate the concept, the condition in this case that we're looking at. And again, there's the SQL and the JSON if you want to put this into your SQL environment and actually bring back the data. Okay, so now that we have our T, C, and O, these are the units that you create outside of the estimation piece. So the estimation module, I guess you'd call it, of Atlas is you click over here on the left in this little estimation bit, and you end up with at this page where you've got a filter on the top and these three headings, and it currently comes set as all, but you would want to specify your study by going through these one at a time sequentially. So the first, you would like to specify your comparisons. So you would add a new comparison. I mean, we already have one, so we don't really need this one right now. But here, I'll just delete it. But this comparison here that we've already specified, to go look at it, you click on it, and here we have some input instructions. Choose your target cohort. You would click this. You would find your cohort. You'd say dabigatran. I don't know if I can spell. There it is. Again, it's already in there, so I'm not going to click it again. We would do the same for the comparator. We've built and saved these elsewhere in our, here it is, Warfarin. Shumi Warfarin. And then we would add our outcome cohorts, which we created before. So here is the, say we want to add another one, we can just pick MI. Let's see if someone has an MI. There's cardiomyopathy. So this is, we're not going to add any of these, but this is how you would add a third outcome to this TCO combination. So our current, and the thing is, between any single TC, you can add multiple O's. So you can have TC multiple O's, but if you start changing your T and C's, then you would add another comparison altogether. You would add negative controls here. If we're not going to go into that at the moment, but if you also wanted to include not just outcomes that you thought were going to be caused by dabigatran relative to warfarin, but you wanted to pick something that you thought should give you a null estimate in order to calibrate your answer, you would enter those concepts here. And then later on you get some choices on how to build those outcome cohorts. For this particular comparison of dabigatran and warfarin, if you wanted to exclude some covariates from your propensity score model because you think they might be so highly associated with warfarin that it would completely separate these groups and make your comparison undoable, then you would enter them here.
Well, yeah, let me add to that.
Please.
So, unlike what Graham did, where they manually selected a set of covariates that they will include in their propensity model, in our tool, the default way of working is we construct every conceivable covariate that we can think of, usually somewhere between 10,000 and 100,000 covariates. So that includes all the conditions and drug classes and procedures and everything. And we just include them into the model, and we let the regularized regression figure out which ones are actually predictive of treatment. The variables that are included is everything up to and including the index date. Because on the index date, you probably see interesting things like the actual indication for which the drug is given. But that also means that if you're just blindly including everything, it will also include the actual prescription of the drug that you're trying to predict. And so if you do not exclude at least the two drugs that you're comparing, then your propensity model will fail because there's a perfectly predictable predicting variable in there.
It will choose exactly one covariate to put into your model, and that is,
It will do a great job.
it will do an excellent job. It will be
So-
perfect.
So unfortunately, there's no real good way of automating excluding those two things. And so you always, I'm afraid that's just the way it is, you always have to at least say what those two drugs are. Because you can define your T and C cohorts in very different ways, so it's hard to figure out what exactly is the drugs that we should exclude from the propensity model. So you always have to say, for this comparison, these are the things that I need to exclude. But it can be as simple as just these two drugs.
Figuring out how to automate that is a black hole as deep as the vocabulary. Okay, so
Yep, go ahead.
yes.
Is there a way to look at all possible outcomes, maybe just do it using take the one for the signal and right?
Yeah, I mean, you could just fill up this comparison here with every outcome under the sun, if you really want. If
No, I think an easier way in Atlas might just be to look at the incidence rates. So your target group are new users of dabigatran and incidence of all possible outcomes.
But if you wanted to, you could do a new user cohort study with propensity score adjustment on for all outcomes. But you would need to construct cohort definitions for all those outcomes.
So that would be really simple, like ever have this ICD-9 code.
You could do that.
and we've done it for a couple of comparisons. What it tells you is subject to interpretation. But yes, you can do it, and the software makes it easy. Takes a while.
Don't construct those outcomes in Atlas.
No. Do not instruct them, not at all.
Write in JSON and just copy and paste.
Yes.
This is more so here you're only looking at one data source, but you have several data sources.
Oh, actually, we've not looked at any data sources.
Right now, we're not.
No, yeah.
So what's going to happen at the end of this? We're going to export an R package that has instruction that has a couple parameters that you need to enter into it, including what data source you want to point this at. So if you want to point it at 10, you just do that. If you want to point it at 10 data sources, you just do that.
But you have to analyze them separately, but you cannot move across all.
I mean, these Odysseus people are creating some software that you can actually do that. But what we're doing now is not. We're going to point it at one data source, and if you want to do it at another, you just point it at that data source in your next run.
But you only need to design it once, and that will create a R package that you can then run, and you can run that package as many times as you want, at as many different databases. But you only need to design it once, because we use a common data model that should make all these databases comparable.
I'm asking that because I read something like Sentinel, where there are different data partners, and there is analysis done within each data partner, but then eventually you can see like one number of results.
Yeah,
across all data partners.
This is the same thing.
That is explicitly what we try to support. So the outcome, the end result of what Jamie is doing is this R package, and you can just email that or distribute it in any other way to partners in a data network. They can run that locally, and out comes at the end basically a zip file that has the results, and they can send that back to you, and then you can do like a meta-analysis across them or whatever you want.
So I think that's all right. Analysis settings. Yeah. So that's what you get in this comparisons setting area. So next we want analysis settings. So we've now defined a TC with 2 O's, and now there are ways that you can set up one or more types of analyses to run against these. And here we've just got one. It's called primary. So you click that, and it takes you into this analysis settings sub area that has 5 different headings. And here we're looking at all of them, but you can filter to the variety of them. And these are where you enter all of the nice stuff that you just read in the paper. So for example, the study population, we've defined our cohorts. Here we don't need to add any dates because we did that in the cohort definition section. The reason that it seems like there's like duplicate places to add your study start date, maybe you think your study results will be sensitive to when it is actually executed. So what you could do is create your cohort with no date parameters, and then create multiple analysis settings that then use the different dates then. So whenever you see things that you think are redundant, there's a good reason that it's in there twice, because it means that you can specify analyses at different points in time or on different subsets of people and whatever. So this is something that I learned getting through this software. Should the first exposure only be included? Should we keep subjects that are in both the treatment and the comparator cohort? You might remember we defined our cohorts to make sure that someone didn't have the comparator, the target or the comparator beforehand, so this doesn't apply to us because we've already made that restriction in the cohort definition phase. But if our cohorts did have overlap and we didn't explicitly define it out of the cohorts, we could here decide whether we want to keep the people that are in both, remove them all, or interestingly, keep in the study the cohort, the patients that entered the cohort first. And there's some nice literature on why you might want to do that. This restrict the analysis to a period when both exposures were observed, and this is useful in pharmacoepi studies because sometimes you only want to study a period of time when both drugs are on the market, because there could be some time effects of looking at index dates where another drug is not available. And then you can remove patients that have had an outcome before the index date. And this is interesting, and this is useful in this context of having modular TCs and Os. You want to make sure if in your particular study you want to have a truly incident event rather than a recurrent event after the drug is started, you just click this and you say remove subjects that have had a prior outcome, and you look back to the dawn of time, and you don't have anybody in your outcome in the study that's had you don't have anybody in your study that's had an outcome before the T or C index date.
So again, this follows from our decision to basically make the T's and C's and O's more or less independent. Normally what people would probably think of is, if I'm defining my T's and C's, I would already there have an exclusion criteria. You can't have the stroke prior. But then if you have multiple outcomes that you want to consider, then you're stuck, because you now need to have multiple T's and C's for the different O's. And so that's why we decided to put it as part of this analysis setting here instead, where you can decide, I want to remove people with the outcome, and then depending on which T, C, and O you're looking at, different people get excluded because they have the outcome prior.
So here, this section is called covariate settings, and this is where you decide what covariates you want to include in your propensity score model. And you remember that Graham and company included, by one definition, many covariates, and by another definition, very few covariates. So like this covariate setting section here leverages a package called feature extraction. And feature extraction is a really great set of instructions to construct covariates pegged off of the index date of some cohort. And by default, it will create covariates for gender. So here's the demographics. Remember socioeconomic factors in the paper? Well, what are they? Well, here are a bunch that by default you can create using feature extraction. There's gender and age groups and race and ethnicity and index year and month, and a couple others that by default aren't selected. The time-bound covariates is basically the look-back window when you start looking for drug exposures and conditions and procedures and things, because a covariate is not just a concept. A covariate is whether a concept was observed at some point relative to the index date. So here is where you set what those look-back windows are. And then you can scroll down and select these era covariates or any of these domain covariates. And by default, we are looking at condition groups, which is a level of the SNOMED ontology. That is, I think, the clinical finding level condition. And then a drug group, which is an RX norm level drug code. And then you look for procedures and measurements and measurement range groups and observations and devices in the 365-day look back and the 30-day look back. And then you've got a couple of these index scores below, like Charlson, Chad-Sugask, et cetera. So by default, feature extraction will construct this style of covariate for every concept in the vocabulary. If you want to do exactly what Graham did and include some selection of 20 or 30 of them, you would put those in a concept set here. And you would say, no, let's see if someone's done it. Oh, look, in covariates to include in the PS model. So here, now we're doing just the Graham ones. But because we don't believe that Graham or anyone really can properly specify a propensity score model on their own, we will leave that blank and let the regularized regression do it for us. And so that's if you want to include. And then additionally, if there are particular covariates that you want to exclude from your model, you can do that here. Again, you might think this is like duplication from before. But yes? It's just, this is another spot where you can exclude covariates from your propensity score model here, or you can do it back at your TC comparison. Yes?
Documentation for the methods that you're using, for instance, regularized regression, is there somewhere here?
It's,
For the methods that are used?
yes, it's very well documented. It's all, I'll send you all the links later. Yeah, so that's how you create your covariate settings.
Oh, wait, I want to add something.
Please.
Sorry for keeping
No,
going.
go.
So first of all, there is a reason why the actual selection of which covariates to include is a bit hidden behind that link there. That is because we think you really do want to use the defaults and not mess with those, unless you have really, really good reasons not to. So that's the first. Take that as it is. And another rather important setting that is a bit complicated is that yes box over there. Should descendant concepts be added to things to exclude? And so you might ask, why is that yes if that box above that is empty? But for the TCOs, we actually defined concepts to exclude. And there I said, oh, just add the 2 drugs that you're interested in. Just add dabigatran and warfarin. Well, if you just add the 2 ingredients there and had this box set to no, that you would only exclude those 2 ingredient concepts, and probably in the data you would not have the actual ingredient concepts, but some formulation of warfarin or dabigatran. And so this box, and we tried to make this interface a little bit more intuitive, but we just couldn't figure out how. But this box works together with that set of concepts that you identified for the TCOs to exclude. So the best thing to do usually is to put the 2 drugs that you're looking at the TCO level, because you might have different TCs, and then here set this box to yes. I'm sorry for making that as confusing as it is, but we didn't find a better way to do that.
There's a very nice paper written by Yushi Tian on comparing the error and bias performance of propensity scores specified in various ways. One is with some expert opinion. One is using a high-dimensional propensity score with a single stepwise, univariate correlation rule for what to include. And then there's the regularized regression, which is the penalized approach to doing it. And the latter outperforms them all quite well. And it's on the basis of this and other work like it that we've made that decision to, you should leave this as it is. It usually does better. Here's the time at risk. These are a collection of parameter options to set where you want to look for the outcome events relative to the beginning and the end of the cohort. It's a little tricky at first, but once you get used to it, you can set your time at risk. Like maybe you want to have a little bit of a lag and you don't think it's appropriate to look for your outcome within the first week of exposure to some drug or after some procedure or whatever. Here is where you would set how your time at risk, where your time at risk sits relative to your cohort index date or cohort end date. Here are some settings for your propensity score model. And we've been calling this logistic regression to this point, and we've also said like regularized regression. So these are all of the parameters that go into that. And if you want to get really deep, you can go into the control settings and to really get into some deep specification. But for the most part, the defaults do quite well, and you can just decide what caliper scale you want to look for your matches if you're matching, or you can stratify, and here are some options for your stratification options. Or if you want to trim, you can say yes or no by percent or equipoise, or you can just turn it off and not match or not adjust on the propensity score at all, which is a nice way to it's a nice way to show how your propensity score matching improves your result. So and then lastly, we're in this outcome model setting where we will either decide whether to look for an event during some, an event, whether it happened yes or no in some fixed period, like with a logistic regression, or if we're looking for rates, or if we want to do a time to event analysis. And Graham and company did a Cox proportional hazard model, so we'll do this. We condition it on the match, on the one-to-one matched sets, and we are not including other covariates in this outcome model. So this is a simple conditional model. Again, more additional settings. If you did want to include all of your other covariates in this model, you could specify something fancy and do another regularized regression.
All right. Oh, sorry. Go ahead.
Yes?
So to do inverse probability weighting, then you would say no to the propensity score adjustment tab and say yes here?
Yes.
Yes.
So just to be clear, we're actually talking about two different models in this approach. There's the propensity model that tries to predict which treatment people get. And then there is the outcome model, which is basically trying to predict, but we don't actually consider the prediction, trying to predict who gets the outcome. Irrespective. Well, and usually one of the variables in the outcome model is the treatment, and the beta that you get in that model for your treatment is actually the effect size that you're reporting. You can choose to put variables into both of those models. You can have a large set of variables in your propensity model, and you can also have those in your outcome model. But the nice thing about putting them in your propensity model is you usually have a lot of people that are both in T and in C, like 10,000 in one and 10,000 in the other. Your outcome model is usually very limited in the number of people that are in both classes. There's usually just maybe 10, 20 people that have the outcome, and then the remaining tens of thousands don't have it. So the recommendation is to basically put all of the weight, or my personal recommendation is to put all of the weight of doing the adjustment on the propensity model. And then when you get to the outcome model, basically the only variable that goes in that model is the treatment. And then you, for example, condition that on the matched strata. And so the outcome model is very simple with really just one coefficient to estimate. And that's because you don't have a lot of data at that point, because you only have usually a few people with the outcome. If you have an outcome that is extremely prevalent, then go ahead and put lots of variables also in that second model if you want. But typically, I would put everything in the propensity model. Yep, go ahead.
Yes.
So what you're saying is, let's say I did want to, like I'm doing a comparator, but I wanted to know the effect of one variable along with that. I could leave that from my outcome model and look at the effect of the two things. In a way, is that something you can do?
You could specify like interaction terms in the outcome model.
Oh, so that, I think we're not talking about two different things. So if what you wanted in your outcome model is you wanted to look at treatment and some other thing,
Let's say
age, then you would, yeah,
Gender.
that is a bit difficult. That is a bit difficult to do when you're also doing propensity score matching, for example, because you're probably already filtering out the effect of the age at that point. You can keep age out, but age is going to be correlated with lots of other stuff. So in general, that's not recommended. If you want to know the effect of age, then basically that becomes a new study where age becomes your treatment variable, where you have to define your T and your C as the two.
Or like what he's saying though, if you did want to see the effect of the two drugs stratified by a variable, you would want to pull that out of your propensity model.
Yeah, so, well, a completely different question is age an effect modifier? And so in that case, what we recommend to do is actually put it in as an interaction term, which means that and so that's actually a new feature that we added. You can do that in your outcome model. Say, I want to look at this covariate as an interaction term, and it will fit the model with that interaction term there.
Just right in that box.
Yeah.
Perfect. Currently set just for interactions.
That's interesting though, because remember our EMA study. The EMA asked question in terms of baseline subgroups. What they really want asking is about the effect modifier or do interaction right. But the Patrick pushed back for every subgroup for baseline, figure out whether you have a baseline food infection. We basically did a separate propensity matching. With food infection, you separate matching. Without food infection, sometimes the subgroup is so small that we make a limitation. But in this situation like gender-given situation, we really did, among males, you did the propensity matching, and among females, we did that one. So it looks at it right now, the tools actually, we can do the interaction to address that question if that's what they wanted.
That's right. But, so it's still a bit of an open question. What if you're going to look at a subgroup, what is the best way to do that? Are you going to have one propensity model that basically spans all the people, including the one in the subgroup, and then put in an interaction term, or are you going to create T's and C's that are just your subgroup of interest? And so currently the solution that I'm rather fond of is you put in so you fit your propensity model on the whole population, you put in the interaction term, but then it is on you to also check whether you achieve covariant balance within the subgroup. And so the tools actually also allow you to do that, exactly that, check for covariant balance in the subgroup.
Sorry.
For weighing, I don't see any extra option. Is it weighing to estimate the average treatment effect in the whole population? Or is there an option to, if you're interested in
That's a good question. I'm trying to remember. I think it's the average treatment effect in the entire population. But I will look that up and then.
you do matching and then you do weighing and you want to get similar results as matching? There's not an option to estimate average treatment effect in the treating.
Yeah, currently we don't have an option for that.
Yes, and it's also important to keep in mind that these are just the options that are given in this GUI. You can always modify the R code that gets generated to fit almost any of these modeling ideas that you have. Not endorsing these modeling ideas, but saying they certainly are possibilities. I mean, you just change the weight to the effective weights.
Yeah,
We're averaging across the whole population. The weights are used in the whole population.
no, so there are different ways of using the weights.
Yeah.
But I need to check the code which one is actually it's doing. But to Mark's point, what you're looking at right now is a nice GUI, a user interface on top of something, and I will actually later on go into the bowels of what is under that, and at that level, if you're good in R, you can actually do whatever you want.
I'd say not quite a balance. Let's go down to the C.
So, yeah, clarify one thing again. So, when you include another factor in the interaction model, test interaction, does that only test interaction also subsequently give you the subgroup of the effect estimate?
Nope. So you get a beta for your treatment, and you get basically a beta for your interaction term.
Okay, so it doesn't give you the subgroup.
It doesn't give you two betas, one for the subgroup and one for the whole population.
Okay.
That's on our wish list. But that's rather complicated to actually do mathematically.
Because right, I think the reason EMA,
No, it's just annoying.
I think the reason EMA or even the FDA also asks a subgroup analysis, they custom to that clinical trial analysis.
Yeah.
They also give you gender, say among female with the subgroup effect.
No,
is
I
like-
agree it's important.
Yeah.
I've just been lazy, so I apologize.
No,
Well, I also think it's asking two different questions.
Yes.
Are you asking the question, what is the effect within this subgroup? Or are you asking the question, is the effect in the subgroup different than in the overall population? And so if you're asking that latter question, you should use an interaction, because the two effect sizes themselves do not actually tell you that. You need to compare them, and then you get into all sorts of trouble with correlation between the estimates and whatnot.
Yeah.
Okay, so this last, Jamie, bring us on the lunch.
We're almost there. We're close. We're close. So this last section, we've gone through comparisons and the analysis settings, are the evaluation settings, and this is where you specify your negative control outcomes so that you can determine whether the T, C, O, and analysis settings that you've decided on can actually return you null effects for outcomes where there should be a null effect.
Wait, I'm gonna
Go.
get between lunch. So when Jamie was defining the T's and C's and O's, there was a spot where you could define the negative controls. At that point, you can define a set of concepts. But as we already explained, a concept or a code set is not a cohort. And so what you can specify here is how you turn those negative control concepts into cohorts. And you just have a handful of options. Basically, do you want to have the first occurrence of that concept in the CDM or any? Do you want to include descendants? And in which tables do you want to look for those concepts? And so it's a very simple way of turning concepts into cohorts so that they're actually outcome cohorts that we can include in our analysis.
And your negative, and what you will expect, or you should expect, is that the occurrences of these negative control outcomes, there's no difference between in the occurrence in the T and the C. And if there is a difference in occurrence, then don't use it. You've specified something wrong, or you should ask the question another way, because the way that you've specified your model can't determine what should be an effective one. If you want to get really fancy, you can specify positive controls, which basically uses negative controls, and then on the basis of that injects signals into people that it would be expected to have one of these negative control outcomes, but it injects them only into the T or the C, I guess it doesn't matter.
Only the T.
Into the T, it injects them into one side so that you end up creating synthetic data with known effect sizes. And here you can say, I want to see synthetic positive controls of 1.5, 2, and 4. And this means that you can then not only calibrate the p-value, calibrate your model p-value against your negative controls, but you can actually calibrate your confidence interval and effect measure to reflect the calibration issues that you might have in your study design. And there's a lot to specify here. It's new and fancy, and people will start using it soon. Any questions before I go to the last bit and we go eat? Nope. So in the utilities section, this is when we take all of the input we've used in this nice GUI interface and turn it into the code that we use to execute across a network of databases. So the first thing you do before you can export it is you need to review your full study specification. And here you get a Cartesian product of your comparisons, your analysis settings, and your, I think that's it, your T, your C, your O's, and your analysis. So here we've specified dabigatran versus warfarin and GI bleed with this primary analysis setting, and then dabigatran versus warfarin for stroke with this primary analysis setting. And you can imagine how if back in the specification area, if we had added additional comparisons and additional analysis settings, we would see additional lines here. So this is where you enumerate the total number of TCO analysis settings that you get, and you'll see this is the number of effects that your study is going to give you. You can filter around over here if you want to look at things, etc. So once you've done this, you can download it. So we'll call this Graham example. Click download. And here it is, Estimation Study 8 Export. And we can save it to my server here. Click Save. And should I open it? You want to look at what has been produced? Martine's going to go through it in detail later. But
yeah, we could have tried to mimic theirs as closely as possible. So in previous runs we've done that, like guess which variables they included. So you can do that. The tool allows you to do that, but we recommend you just throw in everything.
so let's just see if I can open this quickly and we'll take a look. Oh, I did this earlier, so here I promise you this is the same package. But, well, this is it. It's not really too exciting to look at, but,
Jamie, let's,
yes, yeah.
much larger font or not.
But that's okay. I'll be going into detail what this is after lunch.
Larger font's not gonna work in the presentation.
It's not going to work.
All right.
All right, then we're done. This is it, and that's a little too big. So this code to run script is where you would enter your Oh, you guys can't see anything.
Yeah.
Oh, okay. Never mind. What I was speaking about earlier is,
It wasn't personal.
but anyway, it's in this script where you enter the parameters you were asking about earlier. It's like, well, how do you point this to a database? You put in a couple lines of code here, you know, your server credentials, your database credentials, and off you go. Great. Thank you.
All right, so we are caught up on time now.
Yeah.
So it is almost 12:30 and the lunch is still 1:30.
So we have an hour. We've got 5 minutes until lunch, and we'll be
So-
back here in an hour.
We'll be walking around if you have any questions.